Since we are choosing k pairs of integers, we're going to be choosing 2k numbers from the set. Let's let S be the sum of all of these 2k numbers, the sums of all the A's and the B's. So first, we will find the bounds of S. First, we'll start with the lower bound on S, that is, the minimum sum of our 2k numbers. The smallest possible sum we can get is by taking all of the 2k smallest integers from the set. We'll use our formula for the sum of consecutive integers and simplify. So we have that S is at least k times 2k plus 1, and this is our lower bound. Now let's find our upper bound. This is going to be the maximum possible sum of our k pairs. We'll recall first that all of our pairwise sums of A and B, all those sums are distinct, and all the sums are less than or equal to 2009. So S is going to be less than or equal to 2009 for our first sum and 2008 for our second sum. And since we have k pairs, our expression for our last possible A plus B is 2010 minus k. Let's write all of these in terms of 2010. Our first term here is 2010 minus 1. This is 2010 minus 2, and so on. And there's our last term. We have k terms, and so k of these 2010, and then we're going to subtract the sum of these consecutive integers from 1 to k. So we'll use our formula, and this is our upper bound on S. Combining these two, we have that S is bounded by these two expressions. In the problem statement, we're interested in the smallest possible value of k, and we have this expression on the left is less than or equal to S, which is less than or equal to the expression on the right. We're really only interested in k, so we'll just say that this on the left is less than or equal to the expression on the right. And let's see what we can learn about k from this inequality. K is positive, so we'll divide by k, and we'll multiply by 2, and solve for k. K is an integer, and we want to maximize k, so we'll say it's equal to 803. This is a theoretical maximum because we didn't really take into consideration all of the restrictions in the problem. So let's confirm that this quantity is possible. We'll build out a table of our A's and B's. Each B is greater than the corresponding A, and we need to check that the sum is less than 2009. Let's let all of our A's be the numbers up to 803. This will correspond to our 803 pairs. Since our maximum sum is 2009 and we have 803 pairs, this means a potential minimum sum is 1207. Let's start with our maximum sum. We'll use our maximum value of A, 803, to make A plus B equal to 2009. This means B is 1206. I'll put it down here in the table, and our sum is 2009. Let's try our minimum sum. A plus B is 1207, and we'll use our minimum value of A, which is 1, subtracting to get B. We get 1206. This is not valid because all of our B's need to be unique, and we already have it up here. So we'll try A equals 2 and subtract to get B, which is 1205, which is valid. So I'll fill this up here in the second row. This gives us our minimum sum, 1207. Now we'll return to our second largest sum, which is 2008, since all of our sums must be unique. If we try our second largest value of A, 802, B is going to be 1206 again. But if A is equal to 801, then B will be 1207, which we haven't used yet. So I'll put 1207 here for a sum of 2008. We'll try our next smallest sum, 1208. When A is 3, we get B is 1205, which we've already used. So we'll try A equals 4. This gives us B is 1204 for a sum of 1208. We'll do a couple more. When A plus B is 2007, let's skip 800 and try A is equal to 799 because that seems to be the pattern. Then B is 1208. And when A plus B is equal to 1209, we'll skip to A equals 6, and subtracting, we get B is 1203. And we'll fill this in here. Let's see if we can find the pattern. Up at the top, with our minimum sums, these A's are even, and our B's decrease by 1 each time, giving us our minimum sums. We have the reverse going on here with our maximum sums. Our our A's are odd and decreasing, our B's are increasing by 1, and our sums are decreasing by 1 from the maximum. This might be easier to see if we write these out separately for our odd and even values of A. Here are even values of A from 2 to 802, and the corresponding values of B from our other table. To figure out this last term here, I'm just going to count the number of even numbers from 2 to 802 and divide by 2. This means I'm going to subtract 400 from 1205, and this will give me my smallest value for B when A is 802, and then this is 806. And I'll fill in these sums. Now let's list out the odd values of A from 1 up to 803. We'll start by copying from our previous table. This was 1206 and 2009, our maximum sum. I'll calculate the last B in this list by counting the number of odd numbers between 803 and 1 and dividing by 2. That's 401. I'm going to add it to 1206, which gives me 1607, and then these others decrease by 1. And I'll complete these sums of the corresponding A's and B's. No two pairs of our A's and B's can have a common element, so let's make sure that each element is used once. We have odd numbers from 1 to 803 and even numbers from 2 to 802, so that's all the integers. And then up here we continue with 805 and all the consecutive integers to 1205, and then continue down here with consecutive integers from 1206 to 1607. So all of our A's and B's are unique, and all of our sums are unique and less than or equal to 2009. We have 401 sums for our even values of A and 402 sums for our odd values of A. This confirms our earlier assumption that K was equal to 803, and that's our answer. If you'd like me to solve any other math contest problems, please leave them in the comments.